Okay, welcome to the Year 12 or Year 1 Applied Maths course. We're going to split this course into two parts. The first part is statistics and the second part is mechanics. And statistics and mechanics are both different ways that we have of using mathematics to analyse the world around us. Now, statistics you've met to a certain degree at GCSE already. You'll have done things like analysing data with different types of graphs, and you'll have used different types of averages and spread in order to analyse some data. So we're going to take that a little bit more formally now, and we are going to learn different ways of analysing and presenting data. So let's start off with the definition of the word statistics. It's specifically the discipline of collecting, presenting, analysing and interpreting data. So all of these things together form the discipline of statistics. Let's think about some of the words that we're going to use throughout the course and the kinds of things that we need to know about. So, population. A population is the whole set of items that are of interest to us. And I'll come back to that with an example in a moment. There are two ways that you can find out information about a population. You can do it through a census or a sample. A census is where you measure or observe information about every single member of your population. A sample is where you take a subset of the population, where you take a smaller number of members of the population and you take observations from that subset, and you use the information that you infer from the subset to tell you information about the population as a whole. There are different advantages and disadvantages to both of these methods, so I'll go through those first and then I'll give you a few examples to help all the ideas make sense. So a census is really good because it's completely accurate. It tells us exactly what we need to know about every member of the population. However, it's very time consuming because you have to take measurements or observations about every single member of the population, and your population might be huge. It's expensive for the same reason. There are also times where a census is not a good idea because it would lead to the destruction of the items in the population. And also, it's very difficult to process large quantities of data. It takes time and it's complicated. However, if we take a sample, if we take a smaller subset of the population, that can sometimes be a little bit more helpful for us. So a sample is great because it's less time consuming, so it's quicker. It's also less expensive because you're dealing with fewer pieces of information. Fewer people have to respond if we're talking about people. There's less data to process, which makes it easier to process. However, because you're dealing with fewer people or fewer items, it might not be as accurate as a census. You have to hope the information you gather in your sample is a genuine reflection of the population as a whole. As well as that, and leading on from that specifically, a small sample might not give us information about subgroups of the population very well. So it might not even be large enough to infer anything at all of use. Not always large enough to infer anything of use. So there are pros and cons to both of these. Now there's two more words that we'll use throughout this course that you need to be familiar with, two more phrases. The first one is sampling units. In a population, every single item that you're interested in is called a sampling unit. And when you create some kind of list or some kind of way of referencing all of the sampling units, that list or that reference is called a sampling frame. Let me give you some examples. Let's imagine that we want to find out the most popular Marvel movie amongst all the maths teachers in the country, because we know that maths teachers are a bit geeky like this. So our population is all the maths teachers in the country. If we were to do a census, we would survey every single one of them. Now you can see how that would definitely tell us exactly what we needed to know, but it would be hugely time consuming. You'd have to find out who all these people were, where they lived, or send something out to every school in the country. It would be really expensive. It would be a very difficult amount of data to process. You probably need to start using computers and programs in order to do it. However, if we were to take a sample, each of the teachers is called the sampling units. So I would be a sampling unit, Mr. Bick would be a sampling unit, Mr. Alexander would be a sampling unit, and so on. And if you were to list all of us, let's say a numbered list, 1, 2, 3, 4, 5, and so on, that list would be the sampling frame. Now, to use a sample, it's going to be much quicker. Clearly, it's going to be less expensive because you're not asking or surveying so many people, and there's going to be less data to process. However, let's say our sample was just Heybridge maths teachers. How do you know that Heybridge maths teachers are reflective of the entirety of the maths teacher population? You don't. So you don't necessarily know whether or not what you infer from your sample is actually the case for everybody. Now, let's take another example. Every 10 years, starting from 1801, the UK has done a national census every year apart from 1941 because of World War II. So the UK national census is where every household in the country gets sent out a survey to fill in so that the government can find out what we're all like, what kinds of family groups we live in, how big are our households, what religions do we have, all sorts of things they want to know about us, and they do it through a census. So in this case, the population is the entirety of the UK population, and we're doing a census, which means we're finding out all sorts of information and it's generally accurate. Now, if you know anything about these censuses, you know that they're not always completely accurate because people do make up all sorts of things, including religions such as Jedi. But generally, you can assume that it's going to be pretty accurate. But it is all of these things here, and that's why they only do it every 10 years. Now, if we look at example 1 in the textbook, the question says that a supermarket wants to work out how ripe the avocados are in a delivery. And the only way they can do this is by cutting the avocados in half to check them. So let's have a think about this for a second. They're trying to analyse some data, which is how ripe are the avocados. The population in this case is all the avocados in the delivery. Would they want to do a census? Well, the answer is clearly no, and it's for this interesting point here, because if you cut all the avocados in half, you can't sell any of them because they've been destroyed. So a census is sometimes definitely not what you want to do for this particular reason, and that would be an example here. You're obviously going to take a sample. Now, if you took a sample of 1 avocado, then that sample is not going to be large enough to infer anything of use. No way, because you might happen to have the only ripe avocado in the bunch. You might happen to have picked the only unripe avocado in the bunch, but you don't know. So you want to make sure that your sample is big enough that you get useful information, but also not too big that you end up destroying half your delivery and you therefore can't sell them. So, in part B, it says that the supermarket tests a sample of 5 avocados and finds that 4 of them are ripe. So 4 ripe out of 5. So they're saying they think that 80% of the avocados in the delivery are ripe. Now, how do we know if this is an accurate estimate or not? Well, we don't really. The only way we could get any more information is by taking a larger sample. So instead of maybe taking 5 avocados, we could take 10 avocados, and that would give us a better estimate. But like I said before, it depends on the size of the delivery and how many avocados you're prepared to sacrifice. Now, in the next video, we're going to look at sampling and the different methods of sampling. And for now, I'd like you to have a go at exercise 1A.